Hello everyone, this is Mrs. Logus and I will be taking you through section 1.4, which is about circles. We're going to be focusing specifically on the equation of a circle, but first the connection between where this equation comes from based on the Pythagorean theorem and the distance formula. Now, for those of you that were either took PSGA with me or took PSGA or PSG last year, you know that almost everything in geometry is related to right triangles, and good old Pythags, as I call it, your best friend, the Pythagorean theorem, comes in handy quite a bit. So just to remind you about the Pythagorean theorem briefly, remember that the Pythagorean theorem only applies if you have a right triangle. The A side is usually the smallest length, B is the medium length, and C is the hypotenuse, which is always across from the right triangle. So a squared plus b squared equals c squared only applies when you have a right triangle. And another proof you might have seen before is how the Pythagorean theorem relates to the distance formula, or in a way, proves the distance formula. So given this coordinate plane, let me pick 2 points on there, and I'm going to keep the points general. Let's call this first point x1, y1 for the first point, and let's call the second point x2, y2. Now, before the distance formula was proven, what mathematicians relied on was the Pythagorean theorem. And since they did not know yet how to find a diagonal distance, they relied on good old Pythags, meaning they drew a little right triangle because you can count a vertical distance and count a horizontal distance on a coordinate plane. Now, if you think back to the absolute value video, we talked about that absolute value meant distance, and distance was always represented by subtraction. So if we wanted to find this distance here, we would take the second x value and subtract the first x value. So this would represent this change in distance, and this change in distance would be the second y coordinate minus the first. So if we applied the Pythagorean theorem and thought about a squared plus b squared equals c squared, we would say a squared plus b squared equals c squared, but in this case, instead of c, let us call it d, because we're trying to find that distance. So it would be equal to distance squared. Now this almost looks like the distance formula, except what we need to do is take the square root of both sides. And if we do that, we end up with our distance formula. And so a good connection is made here. If I would like to find a diagonal distance, I could use this distance formula that I proved from the Pythagorean theorem, or we could just draw a right triangle and use the Pythagorean theorem itself. And so that will come up later. Now, to continue the connections going, if you take a look at this formula that we just proved using the coordinate plane in the Pythagorean theorem, and compare that to the equation of a circle, they look extremely similar. They have a quantity squared plus a quantity squared equals a quantity squared. This really comes from the Pythagorean theorem as well, but to even just prove it to you, if I have this circle, and I have a center point and a point on the circle, let's call the center point h, k, and let's call the point on the circle x, y. If I wanted to find this radius here, I again could use the distance formula or the Pythagorean theorem. Because the distance formula has already been proven, let me use it. So I would say that this distance r is equal to the 2x values subtracted, so x minus h squared, plus the 2y values subtracted, y minus k squared, equals the radius. This almost looks like this formula, except I would need to square both sides to get rid of the square root. So if I did that, I would get r squared equals x minus h squared plus y minus k squared. This giant square root and that squared cross out. These squareds do not cross out because of the plus sign. So because of the Pythagorean theorem, the distance formula was proved, and because the distance formula was proved, we could use it to eventually find the equation of a circle. So continuing on with the equation of a circle, let's get more specific. H, k represents the center. And so whatever numbers are here and here represents the center point. Now, you just need to be careful. If you're given the center of 1, 4, If you plug that into the equation, these change signs. If you had the center of -2, -3, remember when you plug the negatives into the equation, it really becomes a positive in the equation. And the radius really is r. Now, just again, from geometry to remind you what a circle really is, there's really two major parts of a circle, the center and the radius. So if I had a center here, and let's say that my radius happens to be 3 units, what we would do is from the center, we would count 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and you can keep doing that infinitely until you find the circle. Now, this might be difficult to draw on here. Not terrible. So, a circle is nothing without the center and the radius length, and you could also think of it as a radius spinning infinitely to create a circle. So with all of that knowledge, let's use it to solve some equations. We want to find the equation of a circle. So we want, eventually, to find this. Find the equation of a circle that has a center at 1, -3 and a point on the circle at 5, -2. So there are a few ways to go about this problem. Let's first look at the graph. There's a center at 1, -3, and there's a point on the circle at 5, -2. So from the center to a point on the circle, that really is the radius. So my circle would probably eventually look something like this if the radius spun around. Now what we could do, or what we need, the two major things are the center, which we have, and we need the radius, which we can find. We could use the distance formula to find this length, but I'm going to use the Pythagorean theorem because that's how the distance formula was proven, and usually it's faster. So I'm going to draw a tiny little purple triangle here. This distance horizontally is 1. This distance is going to be 1, 2, 3, 4 units. So if I wanted to find that radius length there, I could use the Pythagorean theorem. 1 squared plus 4 squared equals r squared. 1 plus 16 equals r squared. So that means that r squared equals 17. Now, what's interesting is, yes, to solve for r, you could take the square root, but I don't need r. I need r squared. So I can plug in 17 for r squared, and the center is given as 1, -3. And that center is plugged in for h and k. We generally want to keep the x and the y general in our final answer. So it would look like this. X minus 1 squared, because that's h and that's k, plus y minus -3 squared. To make this answer a little more simple, I'm going to make this double negative into a positive. So my final answer for the first example is this. That is the equation of a circle. Now, let's say you didn't have a picture, or you didn't have a graph given and you didn't want to draw one. There is another way you can solve this problem, using the fact that this point on the circle is really a solution, x, y. So let me redraw or rewrite the equation of a circle. Here's another way you can find the radius. You're given the center of 1, -3. So that means that my 1 is still plugged in for h, and my -3 is still plugged in for k. You could also recognize that because this is a solution, I could plug the 5 in for x, and you can plug the -2 in for y. Don't forget it's minus -3 squared equals r squared. So that's 5 minus 1 squared, 4 squared, plus -2 plus 3 squared, which is 1 squared, equals r squared. This looks extremely familiar to the Pythagorean theorem earlier. You still get 16 plus 1 equals r squared, so r squared equals 17. So you'd plug the 17 in for r squared, and then you would still plug in just for h and k, and you would keep the x and y general. So you get the same answer as the previous. The next example, find and graph the equation of a circle that has endpoints of a diameter at 10, -10 and 0, 14. All right, so let's graph that. 10, -10 is right here. 0, 14 is all the way up here. So this time, you're given the diameter and not the radius. Remember from your geometry days that your diameter is really your radius times 2. And so what you have is a very big circle. This is the diameter. So your circle, again, this is not going to be perfect, but your circle is going to be quite large, and that represents the diameter of your circle there. Okay? So your goal is to find two things. Remember, the two things that matter to find the equation, you need the radius, which we don't have yet, and you need the center, which we also don't have yet. So let's think about this. We need to find the exact center of this circle. How in geometry did we find the center of any segment? If any of you were thinking midpoint formula, great job. So what we need is the midpoint to find the center. So the midpoint is when you add the two x values together and divide by 2 of the two endpoints, and then you add the two y values together and divide by 2. The reason we add and not subtract is because you're trying to find an average or the middle of the segment. So what I'd like you to do is take these 2 points, and I'm going to pause the video, and I would like you to find the midpoint without me first. So please pause now. Okay, so the midpoint or the center I got was 5, 2. So if you didn't get that, please pause and check your work with mine. Next thing I'd like you to do is decide how you want to find your radius. Couple suggestions. Like the last example, you could draw a giant triangle and use the Pythagorean Theorem to find that distance, and then you could just divide it in half to find the radius. If you don't mind me going back for a second, you could also do this method in blue where you plug in a point on the circle and the center and work backwards to find that as well. So I'm going to leave that to you for a second. I would like you to pause again and do whatever method you'd like to try to find the radius of the circle. So please pause now. Okay, so to check back in with you, I did the method 2 ways, and both times I got that my radius was 13. Here is the first way that I did it. I made a giant triangle, said this is a distance of 10, and that was 24, and I did the Pythagorean theorem down here. Got that my diameter was 26, so my radius was half, or 13. Now, this also, fun fact, is a triple. You might remember 5, 12, 13 from geometry. 10, 24, 26 is a 5, 12, 13 triple. If you're interested, we're not done with this problem yet. We haven't actually found the equation, but here is another way you could have found the radius of 13. If you're interested in that, please pause the video now to copy that down and ask questions about that tomorrow. But for now, my final answer would be this. So the center that I had is 5, 2, and the radius that I calculated was 13. So my answer would be x minus 5 squared plus y minus 2 squared equals the radius squared, which is 169, equals this. Final answer. So remember, you need to find the center and the radius. Before going into this example, this next one, I'd like you to please pause the video and copy what I've written below. Please pause now. So what we're trying to do without a picture is determine if a point is on the circle, inside or outside. So I want to remind you from the first slide that the Pythagorean theorem was used to make the circle formula. So if a point is on the circle, the Pythagorean theorem applies, which means that these two values together would equal the radius squared, because this point is exactly the radius distance away from the center. So if it's on the circle, these two sides are equal. If a point is inside the circle, it's smaller than the radius. So that would mean that these two quantities together would be less than the radius squared. And if a point is on the outside, these two quantities squared would be bigger than the radius, because a point, if it's outside of the circle, has to be longer than the radius. So here's an example. Given this equation, where is this point? What we could do is plug in this point and see how it relates to 9. So since I'm running out of time, I'm going to pause the video, do that, and show you how you can answer the question. Please pause now. Here is how I did the problem. We'll be practicing this in class tomorrow.